All right. So to this point, we've talked about how the integral, one definition is the area between a graph and the x-axis. So we're going to expand our definition a little bit. And we're going to talk about the area between two curves. So the area A of a region bounded by the curves y equals f of x and y equals g of x, and by the lines x equals a and x equals b, where f and g are continuous and f is always greater than or equal to g, then the area between those two curves is the integral from a to b of f of x minus g of x dx. So a little picture of what this is saying. We have some graph f of x. We have some graph g of x. Not really drawn well, but so this is, excuse me, this is A, and I don't know, maybe this is B. So to find the area between, you take the integral from A to B of the upper function minus the lower function. Another way to think about it is you're finding the area between the function f and the x-axis. That would be the first part of our integral. And then you're subtracting the area from g to the x-axis to get the area between the two curves. All right, so here we have the area, find the area of the region bounded above by y equals e to the x and below by the graph y equals x, and on the sides by x equals 0 and x equals 1. So in this case, we're told both of our functions and we're given the limits for our integral. That will not always be the case. Many times you have to find the limits, or at least one of the limits, for the integration. We'll take a look at examples of that as well. So the area is the integral from 0 to 1. Upper function is our exponential minus our lower function. All right, integral of e to the x. What is the integral of e to the x? Integral of e to the x is e to the x minus the integral of x using the power rule, 1/2 x squared. And we're going to evaluate that from 0 to 1. Plugging in 1. Plugging in 0. And so simplifying, 3/2, 1.5, 1.5, either of those answers would be fine. All right, questions there? Hopefully this one was pretty straightforward. Made some sense. All right. This is another way that these questions could be asked. So now it just says, find the area of the region enclosed by the parabolas y equals x squared and y equals 2x minus x squared. And it doesn't give us any limits for where that region is. So the first thing we would do is set the two equations equal to each other to find where they intersect. And then solve. So I'm going to solve by moving everything over to the left-hand side. And then set each factor equal to 0. The other thing is knowing which function is the larger and which is the smaller. Now, in this case, I think we could reason which is which because of the minus x squared giving us that upside down parabola. But if we didn't know, what I would suggest, pick a value on our interval, so between 0 and 1, plug it in, and see which gives you the larger y value. So if I took 1/2 and plugged it into y equals x squared, so 1/2 squared is 1/4. And if I plug it into my other equation, I get 2 times 1/2, which is 1, minus 1/2 squared, which is 1/4. 1 minus 1/4 is 3/4. So my larger function is this one. So if I take my integral, the area is the larger function minus the smaller function. And I would always simplify. So combine your like terms. And if you have the need, like I do, I always write my x squared term first. Otherwise it doesn't feel right. Take the integral. So negative 2/3 x cubed plus x squared, evaluated from 0 to 1. I love it when I have polynomials and I have 0 as an endpoint. It just makes things so much easier. Right. Questions? This answer should always be positive because we're talking about area between two functions now, and not necessarily like the area under a curve, which could be negative if the curve was mostly, if the function was mostly negative. This should always give us a positive value because we're always taking the larger function minus the smaller function. All right, so the first part of your assignment, and I think I'm just going to put these as a single assignment rather than two assignments. I think that'll make it easier. So 1, 2, 5, 6, and 7. And we'll get the second part of the assignment here in just a minute. Does anyone need the assignment any longer? Everyone got it? We're good. All right, so the second part still doing more on area, which I just added a little adjective there, even more on area. Because functions aren't always written as y equals a function of x, or it's not always one function being above the other, we will introduce this other possibility. And that's when we need to write the equation as x equals a function of y. So it's the same idea. The only difference is now we have y as our variable instead of x. Nothing else changes. So we will have x equals some function f of y and x equals some function g of y. And then our endpoints will be the y values, c and d. And here, instead of f being above g, f would be to the right of g. So again, I don't know, something like this maybe for, I'm gonna make that my f. Make this my g of y. And there are my values c and d. So that would be this area in here. All right, so here we have find the area enclosed by the line y equals x minus 1, and the parabola y squared equals 2x plus 6. So I'm going to graph it, and then we can take a look at finding the integral. So y equals x minus 1. Hopefully we can all agree that's going to be a line, slope of 1, y-intercept of -1. Looks something like that. For this second equation, this is one where, again, solving for x might be helpful. So if I subtract 6 from both sides and divide by 2, man, there we go. And then I would just pick some values for y. So, 0 would be a good value. And if I plug 0 in, my x is -3. You could pick a y of -1. This would be -2.5. And if I pick +1, I'd get -2.5. Pick y of -2 and +2, and that should give us a pretty good picture. Half of us is -1. And at +2, I also get -1. So we get this parabola sitting on its side. And we want to find the area in between. So there are a couple of ways to do it. And some work better than others. You could look at the graph in two pieces. I think this is the more difficult way, but you could look at it this way and find this area and then find the other area. Or you could write it as a function of y in terms of x. And you would need to, what in the world is that? Convert the other function and then just do one integral, because the parabola is always to the left of that blue line in the enclosed area. And then find our limits. So if I set these two equal to each other, ½ y squared minus 3 equals y plus 1. It might be a good idea to multiply everything by 2. Just to eliminate the fraction in front of the y squared. If you don't have to, it will still be solvable. So we get our limits as 4 and -2. So our area is going to be the integral from -2 to 4. Again, the linear function is on the right side. So again, if you weren't sure, you could pick a value between -2 and 4, like 0, and plug it in for y. And so this would give me x of 1, plugging in x of -3. So this is my larger function. And then -3, yeah. And it's in terms of y. Just so you're aware, on a problem like this, if you use your calculator to find the integral, you can certainly just change the variables to x's. And it will, because the integral does not depend on the variable. Again, I would combine my like terms and simplify this a little bit. Plus 4. And then integrate. Um, 4 cubed is 64 times -1/6. I'm just going to write that as -64 over 6. And I'll reduce things if I need to. 4 squared is 16 times 1/2. That's pretty easy. -2 cubed is -8 times -1/6 is +8/6. Half of 4 is 2. Excuse me. So this is -64/6 minus 8/6 is -72 over 6, which that'll be pretty easy. 8 plus 16 is 24. Minus 2 is 22. minus -8 is positive 30. So we get -12 plus 30, which is equal to 18. So again, the answer should always be positive. If you get a negative answer, one reason could be that you had the wrong function first. So if you took the smaller function minus the larger function, you're going to get a negative value. Okay, so go back and just switch your functions around, and that should give you the positive answer that you're actually looking for. On the AP exam, if you were doing this problem and you had the functions backward, my suggestion would be, if this was on the free response part, redo the problem, and then when you're done, cross out the wrong part. If you don't cross it out, it will get graded. And there'll be an average between your wrong part and your right part. And that's how they'll calculate your final grade for that particular problem. So don't erase. That's just messy. Cross it out. All right, so there's the rest of your assignment. Any questions?